All right, 6-3, proving that a quadrilateral is a parallelogram. All right, so some vocabulary. Does a pentagon have opposite sides? No. Does an n-gon have opposite side if n is an odd number? No. So draw a line from each side in column A to the opposite side in column B. So AB is opposite DC, and AD is opposite BC. So a parallelogram is a quadrilateral with two pairs of opposite sides parallel. Opposite sides may include arrows to show the sides are parallel. All right, write P to describe if the statement describes a parallelogram, or NP if it does not. So an octagon is not a parallelogram. If it has 5 congruent sides, it is not a parallelogram. If it is a regular quadrilateral, it is a parallelogram. All right, let's plot these figures. Number 8 looks to be a parallelogram. Number 9 looks to be not a parallelogram. And number 10 looks to be a parallelogram. Okay, so we have another group of theorems here. So theorem 6-8, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Theorem 6-9, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then a quadrilateral is a parallelogram. 6-10, if both pairs of opposite angles of a quadrilateral are congruent, then a quadrilateral is a parallelogram. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So use the diagram at the right, and we're going to mark these things off. So if I know AB is congruent to CD, and BC is congruent to DA, then I know this is a parallelogram. I also know if A plus B equals 180, and A plus D equals 180, then this must be a parallelogram. If I know that angle A is congruent to angle C, and angle B is congruent to angle D, it must be a parallelogram. If I know AE is congruent to CE, and BE is congruent to DE, then this must be a parallelogram. And if BC is congruent to DA, and BC is parallel to DA, then this must be a parallelogram. Or if I know CD is congruent to BA, and CD is parallel to BA, then it must be a parallelogram. So that's an illustration of all those theorems we just saw. All right, let's use some properties of parallelograms to find the value of x. So circle the equation we can use to find the value of y, and underline the equations you can use to find the value of x. All right, so I would first use this equation to solve for y. After I have this for y, I would use this equation to solve for x. So let's do that. We have the equation y plus 10 plus 3y minus 2 equals 180. Simplifying, we have 4y plus 8 equals 180. Subtracting 8, we have 4y equals 172. Divided by 4, we have y equals 43. All right, using the other equation, y plus 10 equals 4x plus 13. Substituting in, we have 43 plus 10 equals 4x plus 13. Subtracting 13 and adding 43 and 10, you get 40 equals 4x, so we have x equals 10. Now, we could have used a different equation to find x first. So we could have used the equation 4x plus 13 plus 12x plus 7 equals 180. EFG must be parallelogram for x to equal 10 and y to equal 43. Okay. All right, can we prove the quadrilateral is a parallelogram based on the given information? So if I know that EF is congruent to GD and I know DE is parallel to FE, can I prove this is a parallelogram? All right, so circle the angles that are consecutive with G. That would be angle D and angle F. All right, same side interior angles formed by parallel lines cut by transversal are supplementary. Okay, so underline the interior angles of the same side of the transversal and circle the angles in the same side transversal DG. So D and G are the interior angles of transversal DG, and E and F are the same side of transversal E and F. So can I prove that this is a parallelogram? The answer to that is no. An angle of DEFG is not supplementary to both of its consecutive angles. So, theorem 6-9 does not apply. All right, so a truck sits on a platform of a vehicle lift. Two moving arms raise the platform. What is the maximum height the vehicle lift can elevate the truck? And explain. All right, so do the lengths of the opposite sides change as the truck is lifted? The answer to that is no. The least and greatest possible angle measures for P and Q are 0 and 90. The greatest possible length is when P and Q are both 90. So what is the maximum height that this truck can get? And that's going to be 6 feet. Okay, so the maximum height occurs when the angles are 90 degrees and PQRS is a rectangle. Okay, so how does 611 in this lesson differ from 6.6 in the previous lesson? All right, so theorem 6.6 states that if a quadrilateral is a parallelogram, okay, so this is the hypotenuse, then its diagonals will bisect each other. 6.11 says if the diagonals of the quadrilateral bisect each other, so this is now the hypothesis, then I know the quadrilateral is a parallelogram. So draw a line from each statement of column A to a corresponding diagram in B. So quadrilateral is a parallelogram would be this. Diagonals of a quadrilateral bisect each other would be this. So circle the word that describes 6.6 and 6.11. Well, they are both converses of one another. So we would use 6-6 to use properties of parallelograms. We would use 6-11 to prove a quadrilateral is a parallelogram. And that's the end of this section.